that's a perfect analogy, is having like a good neighbor approach, saying, look, we're here now, we look ugly, we're always a box, but we help, powering your homes. We reduce the cost of the energy transition, and we also heat your homes.
Hello, and welcome to Environment Variables, brought to you by the Green Software Foundation. In each episode, we discuss the latest news and events surrounding green software. On our show, you can expect candid conversations with top experts in their field who have a passion for how to reduce the greenhouse gas emissions of software. I'm your host, Chris Adams. Hello, and welcome to another edition of Environment Variables, where we bring you the latest news and updates from the world of sustainable software development. I'm your host, Chris Adams. How do you green the bits of a computing system that you can't normally control with software? We've discussed before that one option that you can do might be to shift where you run computing jobs from one part of the world to another part of the world where the energy is greener. And we've spoken about how this is essentially a way to run the same code, doing the same thing, but with a lower carbon footprint. But even if you have two data centers with the same efficiency on the same grid, one can still be greener than the other, simply because of the energy gone into making the data center in the first place, and the materials used. So does this make a meaningful difference though? And can it make a meaningful difference? I didn't know this, so I asked Karl Rabe, of the founder of WoodenDataCenter and Windcloud, and now increasingly involved in the Open Compute project, to come on and help me navigate these questions, as he is the first person who turned me onto the idea that there are all these options available to green the shell, the stuff around the servers that we have, that also has an impact on the software we run. Karl, thank you so much for joining me. Can I just give you the floor to introduce yourself before we start?
Thanks, Chris. This is an absolute honor, and I'll have to admit, you're a big part on my carbon-aware journey, and so I'm very, very glad that we finally get to speak. I'm Karl, based out of North Germany. We initially, I always say, I had one proper job. I'm a technical engineer by training, and then I moved into the data. Then I fell into the data center business. We can touch on it a little later, which was Windcloud, which remains, which was a data center thought from the energy perspective, which is a very important idea in 2025. But we pivoted about 4 years ago to WoodenDataCenter. Probably can touch upon those a little later. In also realizing there is the supply chain component to the data center, and there are also tools to action against those. And I'm learning and supporting and providing, as a co-lead in the data center facilities group of the OCP, where we work, with the biggest organizations directly in order to shape and define the latest trends in the data center, and especially navigating the AI build-out in somewhat of a sustainable way.
Okay, cool. And when you say OCP, you're referring to the Open Compute project, the kind of project with Microsoft, Meta, various other companies designing essentially open source server designs, right?
Correct. That is initially started by then Facebook, now Meta, in order to create or to cut out waste on the server design. It meanwhile involves and grew into cooling environments, data center design, chiplet design. It's a whole range of initiatives, very interesting to look into, and happy to talk about some of those projects.
All right, thanks, Karl. So if you're new to this podcast, my name is Chris Adams. I am the Director of Technology and Policy at the Green Web Foundation, a small Dutch non-profit focused on a fossil-free internet by 2030. And I also work with the Green Software Foundation, the larger industry body, in their policy working group. And we're going to talk about various projects, and we'll add all the show notes to all the links we can think of as we discuss. So if there's any particular things that caught your eye, like the OCP or WoodenDataCenters, if you follow the link to this website, to this podcast's website, You'll see all the links there. All right then. Karl, are you sitting comfortably?
I'm sitting very well. Yeah, perfect.
Good stuff. All right then, I guess we can start. So maybe I should ask you, where are you calling me from today, actually?
I'm calling you today from the west coast of the North Sea shore in northern Germany. We are not a typical data center region for Germany per se. Which is Frankfurt, because of the big internet hub there. But we are actually located right at within a wind farm, in my home, which is initially was home growing up, and Corona turned to my home office, and eventually to what was somewhat considered the international headquarters of WoodenDataCenter. And we're very close to the North Sea, and we have a lot of renewable power around us.
Oh, I see. Okay, so near the north of Germany, near Denmark, where Denmark has loads of wind.
Correct.
You've got the similar thing where, okay, so...
Yeah, absolutely, yeah.
Oh, I see, I get you. Yeah. So, all right. For people who are not familiar with the geography of like Europe, or Northern Europe in particular, the north part of Germany has loads and loads of wind turbines and loads of wind energy, but lots of the power gets used in other parts of it. And so Karl is in the windiest part of Germany, basically.
That's correct, yeah. We basically have offshore conditions onshore. And it's a community-owned wind farm, which is also a special setup, which is very easy to get the people's acceptance. We have about 1 megawatt per inhabitant of this small community. And so this is becoming, the biggest economic factor of the small community.
Wow, 1 megawatt per... Okay, so just for context, for people who are not familiar with megawatts and kilowatts, the typical house might use maybe about half a kilowatt of constant draw on average over the year. So that's a lot of power per person for that space. So that's you're in a place of power abundance compared to the scenario people are wondering, where's the power going to be coming from? Wow, I did not know that.
No, that is that is the so a bit of that background, so to speak. We are now trying to go from 300 megawatts to 400 megawatts. There has been, Germany is pushing for more renewable energy, and we have still some spots that we can, under the new regulations, now build out. And the goal or the big dream of our organization, the company running this wind farm for us, is trying to produce 1 billion kilowatt hours per year. And so we're now slightly below that, and we're trying to add another we need to reach probably another 25% more production. And it is, so to speak, you're absolutely right. We are in an energy abundance, and that was one of the prerequisites for Windcloud, because the easiest innovations is 1 and 1 is 2. So we had energy. I was aware that we also had fiber infrastructure in the north to run those set wind parks. So we said, why don't we bring a load to those? That was the initial start of Windcloud.
Okay, so maybe we should talk a little bit about that. I hadn't realized the connection between the geography and the fact that you're literally in the middle of a wind farm, which is why this came together. Okay, so so as I understand it, and now this makes sense why you were so involved in Windcloud. So for context, my understanding of Windcloud is it's essentially a company where, rather than like connecting data centers via big power lines to like somewhere else where the actual generation is miles away from where the data centers are, the idea was instead to actually put the data centers literally inside the towers of the wind turbines themselves. So you don't need to have any cables. And you've obviously got green energy because it's right there. You're literally using the wind turbine. So apart from this sounding kind of cool, can you tell me why you do this from a sustainability perspective in the first place?
Yeah, so the way we discovered that, I wanted to, and this is the probably the biggest reference that I can give on the software developer front. I came out of a study in the UK. Mm-hmm. We had a really nice cohort. We were constantly bouncing ideas off of each other. I wanted to actually build small aircrafts. Because we have a wind farm and we have help with that, we actually have people building small planes in our location. They told me I needed about 5 million euros to do it, which I didn't have. So I started pivoting to a software idea. And via the software idea to host that, I just quickly discovered, the amount of energy going into data centers, the amount of, associated issues. And back then, 2015, 16, we were literally just discovering the energy aspect of it. We didn't discuss, water and land use and all of that. We should really focus on the energy. And then we said, look, well, wait a second, we have all this excess of energy. We literally cannot deliver that at this point. So we have a very high share of shutting down our wind turbines when there's just too much energy to move it around. Why not bring the data center as a flexible load close to the production and enable, sustainable compute to then send packets rather than energy, which is way easier, over the global fiber grids. And that's how I got started and fell into the data industry. Big benefit and big learnings from that stand that I didn't know nothing about data centers. And as an engineer, a lot of things were not adding up. We looked at the server spec back then, and even then it said, okay, this is good, to run from 15 to 32 degrees. And said, 32 degrees? Why? What is data center cooling, and why is data center cooling? We don't have 32 degrees in the north. Most likely now we probably also do within 8 years. But the important thing was really challenging this, and we started with very, very little money, and we couldn't afford like the proper fancy stuff that all of this data center make, like a chillers, spending electric energy to cool something, which really does not need cooling, in my opinion, up to now. That was the start of this, And so this is, the company of Windcloud is still ongoing. We had what we had as a huge problem. And I was always, my gut feeling for this was always, we need to find a way to be able to compete with the Nordics. So we have renewable energy, but we need to have it cost effective. And that was something that we tried two and a half times, I would say, with always having a legal way to access the energy in a proper setting. It was always extremely difficult and extremely frustrating also, because the German energy system is very, very complicated. It is, geared or developed from a centralized view of this, and is benefiting, large-scale industry and large-scale energy companies. Putting out of the terms, as you're probably familiar with the Asterix comics. We are that far off and north in Germany that probably people, there was a bit suspect, what we're doing there. Or now we start producing energy, and now we also want to use the energy. So that is not adding up. It's very hard and close to impossible to access your own produced energy at scale, which is in an abundance. And that was something what we always faced, which led to other innovations. So we built the first data center, or one of the few data centers to reuse the heat in Germany, putting into an Algae farm. And we tried to create really efficient PUEs already back then, whereas the industry standard is still quite high. And I always claim I never had enough money to build a data center with a PUE above 1.2 or even 1.1. The first servers were cooled with a temperature regulated fan, built with the same guy who built a pig stale for my father. So that was we nearly didn't call it Windcloud. We nearly called it swines and servers, but
okay, pig cloud.
Pig cloud. But it could have been misleading. The good thing turning out of that, and going back to that, to those struggles and getting started, is that we were forced to uncover a lot of the cooling change and the energy distribution change, which were not really adding up for us. And that is, still one of the biggest support for us to build efficient data centers and to create, sustainable solutions.
Okay, cool. All right then. So, okay, I didn't realize anything about the Schweins und servers aspect at all, actually. Would you even, I'm not sure what German is for server would actually be in this context. Was it literally going to be Schwein und Zelva or
Yeah, something like that. Yes.
Okay, wow, that's I was not expecting that. I think Windcloud sounds a bit better, to be honest.
Yeah, thanks. No, the brand, the name is great. I think we still, very simple like that. We had Windcloud, so we take wind, we make cloud. Now we are
Datacentres, they're made of wood.
Datacentres out of wood. So there's this, but it's to be fully honest, is right now is so to speak, we call WoodenDataCenter, but what we do is try to decarbonize the data center.
Okay.
So wood is obviously a massive component of that, but we do see real good effort in the supply chains. Happy to go into that a little later, but there's some examples from fluids. We just found, bio-based polycarbonate for hot and cold light containments. So the amount of components throughout the data center that has a bio-based, ergo a low carbon alternative, is ever so increasing.
I see. Can I come back to that a little bit later? Because I just want to touch on the wind thing.
Yeah.
So basically, Windcloud, the big idea was putting data centers in the actual wind turbines themselves. So that gives you access to green energy straight away, because you're literally using power that otherwise either couldn't be transmitted because the pipes weren't big enough, essentially, in some cases. And I guess there's a plus point to that, in that if you're already using a building that's already there, you don't have to build a whole new building to put the data centers inside. So there's presumably some kind of embodied energy advantage there, because there's a lot of energy gone into that goes into making concrete and stuff that you don't have to do because you're already using an existing building, right?
Yeah. So to clarify on that, it's good that you touch on that, because there's literally a bit of a crossover, because the company we're referring to is Windcores, which is a good friend of us, and they are using the turbine towers. They can do so because they use a little bit different type of turbine, and they're also based in the south of Germany. We had the same idea, because it's also very difficult to build next to wind farm. The big difference is that the towers used at Windcores, they are concrete, and they have quite a lot of space. They are about 27 meters wide. Because of the initial discussion that we have onshore or offshore conditions onshore, we have steel towers which are shorter and hence don't have this big diameters. We can build it tall.
Okay.
And so we always had the challenge of still needing a data center, and so that's where our learnings, inspirations came from for WoodenDataCenter. But we still tried to reuse existing infrastructure. So we were at one point within the Windcloud journey, I was the co-owner of a former military bunker area. And so we wanted to place within those long concrete tubes, we want to place data centers in order to have a security aspect and don't need a lot of additional housing or even bunkering. And there's obviously the Deutsche Bundeswehr has spent a lot of concrete and steel and concrete in order for those facilities. So
I see. So you'd be reusing some of the existing infrastructure. So rather than building totally new things, you're essentially reusing you're reusing stuff that's already had a bunch of energy and emissions spent to create it in the first place. I see. Okay. All right. So
and back then, also to recruit, because it's such a short time. Back then, I really need to emphasize that we really only had a hunch and a feeling. A server has CO2 associated to it, and probably also the building of a data center. We really, it was so hard to quantify, and I think we still carbon accounting still is somewhat of not wizardry. But it's really hard to pull the right numbers. Only 2 years ago at the OCP summit, so in a Google presentation, the range that they mentioned, for steel and concrete carbon was, 7 to 11 for equally both. So the range of the total uncertainty, I feel is quite high. And this is one of the biggest and most best funded organizations in the world, we're still not being able to get it more concrete, and that's something we really need to work with the industry and supply chains in order to be even aware to specify the problem.
So can I unpack that for a second before we talk a little bit about this? And so you're basically saying even the largest companies in the world, they don't necessarily have that good access to know what the carbon intensity of the concrete they've used in one data center compared to another one. It can vary quite a lot. Is that what you're saying there?
So this was basically specifying the global numbers for steel and concrete. So
I see.
I do believe that we have now relatively good visibility for our own builds and projects, and also what we do now moving forward. But to really try to grasp the global problem of it, that was still, 2 years ago, had this high uncertainty, because we were working with numbers that maybe then are 5 years older. We don't know the complete, build out of every city, every building globally. It's just a lot of guesswork in that globally. And so I especially believe that although we are WoodenDataCenter, the amount of innovation that is put into concrete, has the potential to drastically reduce that for buildings. But it's definitely still a huge problem for the data quality and the data, the emissions, guesswork that's in there, and a lot of those things are based on scenarios, and those are getting ever so more real. But the best example for WoodenDataCenter is there's a comparing a steel concrete building to a CLT one. And it is assuming that after 20 years, that's only living for 20 years, which, can easily be 200 years, but that afterwards it is being reduced into, building chairs or tools or toys. But if you take then the CLT and burn it, then obviously you have a zero-sum game,
So CLT here is...
that was stored is cross-laminated timber.
So this is the kind of like the special, it's a special kind of, it's essentially like machined timber that provides some of the kind of strength properties of maybe steel or stuff like that, but is made from wood basically, right?
Correct. So we need to stretch the hypothesis that this is a material innovation. It's a relatively young material based on a PhD thesis from Austria. Mm-hmm. And so we only have CLT or cross-laminated timber for about 25 years.
Oh, so I see. Okay.
Or maybe now 26 years. So you probably are familiar, or you have seen there are those huge wooden beams in storage buildings.
Yeah.
Those are called GLT, like glue laminated timbers. And the difference is those boards are basically glued in one direction. And they are really good for those beams or for posts. But to have like ceilings, walls, and roofs, those massive panels, you now have the material of cross-laminated.
In both directions, right? Yeah.
Correct. And those now enable like full massive wooden build-outs.
And
that's something. And so the biggest challenge is that if we say wood, then the associations probably will touch on now or later is fire.
Yeah.
But in reality, in nature, we don't have those massive panels which don't just flame up. They are fully tested and certified to glim down, which is they turn black, and then they slowly at 1,000 degrees they slowly shrink
like
down,
smolder, right? Yeah.
And so, but how we design data centers is basically factor in this component, and we are able to create really, really fire secure data centers built out of those new wooden materials, basically.
Okay, all right. So a lot of us are typically thinking of data centers as things made entirely with wood, with steel, concrete, and plastic all over the place, and essentially, you can introduce wood into this place and it's not going to burn down because you have this material which is treated in such a way so that it is actually very, very fire resistant. And that means you could probably replace, maybe you could talk to me a little bit about which bits you can replace. Like, would you replace like a rack or a wall or like a roof? Maybe we can talk about that so we can make it a bit easier to kind of picture what this stuff looks like.
No, absolutely. I'm afraid I'm still always very limited in sending out samples to my clients, but I don't have it here in my hand. But so that is a very good. The question is basically like if we would talk like slide decks or something, is something that I'll try to show in terms of scope 1, 2, and 3, what we can do or what we have now, and that is like the biggest component is then obviously the housing. What is your building or your room of a data center. When you were touching on existing buildings, we have CLT is also ideal for building and building concept of existing large storage or logistic buildings to put in data centers. We can build that quite quickly out or create rooms very quickly in those. And there's another huge advantage of CLTs that we get those pre-manufactured and they just fit,
like
to the
stick
millimeter.
them together like Lego rather than having to pour concrete, right?
Little bit. You need like a little bit of leveling foundation if you have an existing floor. Still, some data prefer to in the greenfield also to have a new floor. But that is something that it helps to with those. We can create the IT room relatively quickly and then have the build out of those, averaging up to 40% quicker build times than traditional steel sandwich concrete, data center. So it is enormously easy to work to. It's very precise to pre-design and pre-manufacture, and it's then very easy to work with. If there's a problem on site, you just crank out the chainsaw and adapt and adjust.
Okay, just to calm it down a bit.
So to speak. But once you have then those assembled and secured, it has like a lot of mass to it and a lot of volume to that, which creates very good fire protective, physical resistance and availability properties. And that is something that we now it's really being seen as one of the core benefits. The speed with we can build this out.
Oh, okay.
We have introduced wooden racks, and we also see more and more attention for those.
Wait, sorry. Can I just? You said when you rack, like as in the big steel rack that holds the servers themselves. That could be made of wood as well now. So you'd have like a rack thing holding a bunch of servers, right?
Correct. So we built this. Yes. This also, we have one of our clients has sent us like a server casing and asked to also think about to do the casing, but we're not 100% there yet. In order to do that. We would have an idea in terms of the spirit of OCP, which is like reduce and cut out stuff. One vision of that would be just a wooden board where you have dedicated spaces. You slide in your main board, connect power, connect liquid cooling, have fans on the back, and then cycle through only the boards, remove not even fancy but just base frames of a server. But right now, it's a combination for the 19-inch standard and also the OCP standard to use, reduce up to 98% of the steel in those constructions, and then only have functional parts in order to stick in the servers made from steel railings and have then wooden frames. And we do that for the OCP format, which is very, very popular. We get a lot of the special requirements because we're the only ones producing like a small version of the rack, which the OCP has a lot of advantages, but the base rack format is 2.30 meters high, which is like a really hyperscale, mass density approach, which doesn't fit even through the doors of most data centers I know. They still have relatively, standard 2 meter high doors or able to fit in like a 42-inch rack. But you need like very special facilities because those racks come also pre-integrated and then you roll them in place. So you need a facility that has high doors, ramps with small inclines, or no ramps at all in order to be able to place a fully integrated rack. We started building OCP racks because back at the time, only hyperscalers were really getting those. And we wanted to do more of this open compute format. We were able to offer that. And the version 3 rack, was a good candidate to convert to a wooden-based construction.
So we'll come to that a little bit later because I actually came across some of your work when you were designing some of these on YouTube. so people can see what all this stuff looks like. But if I just come back to the original question, essentially, so it sounds like you can replace quite a lot in a data center. So you can replace the shell of the building, like literally green the shell by replacing the concrete, which is one of the largest sources of, creating concrete and cement is one of the largest sources of emissions globally. So you can move from a source of emissions to, is that a sink? Because CO2 and carbon gets sucked out of the sky to be turned into trees. So you've gone from something which is a source to a sink, and you can replace not just the walls, the outer building, but also quite a lot of the actual structure itself, just not the servers yet. So that's probably maybe I could ask you then, if I'm switching from maybe regular concrete and regular steel, is there do you folks have any idea about what the kind of changing quantitative terms might actually be if I was to have an entirely concrete, entirely steel data center and then replaced all of that with, say, wooden alternatives, for example? Is it 5% reduction, or is there any what kind of changes are we looking at for the embodied figures, for example?
Yeah. So the conservative industry figures are somewhat off between minimum 20%, only having the production change up to 40%. So Microsoft, the good thing also we have to mention is that we are an industry now. Microsoft announced those productions. I know the other hyperscalers are looking at that. We only in Germany, we had two other companies started getting into construction. That's why it's for us really important to be on the decarbonization path.
I see.
We do come with our own data center, even concepts and philosophies, which I can talk about a little later. But coming back to the point that it's still very hard to quantify, but really positive things about carbon accounting or calculations. As I mentioned, we now have, as a data center, we have this negative component, which I have to laugh because an engineer immediately said, can we then just use more wood? Can we make the wood bigger? Obviously, yes, you could do that, but there's a cost to that. And there's also, it betrays the idea, but the really exciting thing is that I now go from show to show, and I was 2 weeks ago in London, and just on the flight, somebody showed me a picture of an air handling unit inside of a wooden enclosure, and I was chasing an hour through the London show because I assumed it was there, but it was on a different show. But that is the kind of things that we can really think about is enclosures. So also we have started, we have one for the OCP rack or for this AI build out, we have also created a rear door, which is, so to speak, a wooden rear door. So the fans are traditional, the heat exchangers obviously needs to be traditional, but it is also like a aluminum micro channel heat exchanger, which is derived from other industries, which is, helping mass production, reducing costs, reducing emissions. And that is the other thing that is happening in the industry, that we're trying to find not data center specific solutions, but rather find mass-produced industry solutions and adapt them to the data center and enhance reducing cost and time.
All right. So in the same way that basically cross-laminated timber and the use of wood is something that has been in use in not just in the data center industry, like people make, what are they called? Are they called ply scrapers? Skyscrapers with wood, ply scrapers.
Yes. Yeah.
So the idea was that, okay, things which are being made in volume here can be made more efficiently. And this is one way that you're adapting into a new domain. And it may be that if people are getting much, much better at making, say, very efficient heat pumps, because they can cool things down as well as heat them up, that might be another thing you're looking at and say, well, actually, that might be able to be used in this context as well. Okay, all right. And if I go back to the original thing about saying, okay, we're looking at possible savings, maybe 20% up to possibly 40%. That's the kind of ballpark.
That's the range that we have. I think so. The problem is, did Microsoft evaluate with IT or without IT? So for the facility, I think we can potentially come to net zero approach, which by first principle, I think we can at least achieve realistic reductions to, let's say, 70, 80, 85%, with those tools that I said, basically the easy steel replacements, the rack, the enclosures, the housing, fluids is something we have. There's a very interesting, no-brainer replacement for fossil diesel on backend generators. It's a liquid called HVO 100.
Yeah, let's come to that in a second, actually, because I did want to ask a little bit about some of the things you can do for the fuel here. So maybe if we just so basically so there are some savings available there, and these should be something that you could this is something that should show up in some kind of numerical description. So if you had like maybe 2 data centers and one was using wood in strategic places, then the embodied carbon should be lower. So if I was looking for this, is there like a label to look for or a standard I can look for? Because in the Green Software Foundation, we have this idea called software carbon intensity, which includes like the carbon intensity of the energy you use and stuff like that. But they also look at the building itself. So theoretically, if you had a wooden data center and a bog standard concrete data center, if you ran your code in the greener data center, you would probably have a better score if you had access to the data or stuff like that. Do you know, like, do any places share this data or have like a label for anything like this?
They definitely share the data. For example, so we definitely also need to mention eco data centers in Sweden, which were, basically we approached to them. Our whole world was shook, It's like, oh, so we come from this energy perspective, but they didn't have that idea and they build it, sustainably. They build it sustainably, so we need to change, That was, it was a huge eye opener, and they also are were first ones to. I'm not sure if they use like the LCA method, but they were quantifying the embedded carbon and are certifying to you annually as a client, which I think is the way to go, and we need to figure out how to standardize that. I assume there's potentially a standard that we can use. I know that other data center providers are building sustainably and putting this effort forward, but we don't have a unified label yet, I'm afraid.
Okay, well, it seems
I know that some also challenge, like there's like a Data Center Climate Neutral Act, and some of them specifically exclude Scope 3, which, I know where they're coming from. Also in Germany, Germans, they're all about energy efficiency. They love to talk about, just the energy and the Scope 2, basically. But then,
most of the footprint is actually the other part.
This dimension, missing out the dimension is being faithful to your girlfriend or wife, like 3 days out of a week. It is. It's not really.
You're not showing the full picture, right?
Yeah. You're not doing it at all. Basically, right? I would probably, just need to Google it, and there are, building labels that could be used in construction quantifications, I'm sure, but there's not yet like a data center specific label. There is good work also in OCP to do metrics and key performance indicators, and they're all looking at that. And there is, I think they're trying to build towards something like true net zero.
Yeah, okay.
But
so there are some initiatives going on to kind of make this something that you could plausibly see, but it's quite early at the moment right now. So like, let's say that we spoke before about, okay, I can run my computing jobs in one data center, or I can choose to run it somewhere else. These numbers don't show up just yet, but there is work going on. Actually, I've just realized there is actually a embedded carbon working group inside the OCP who have been looking at some of this stuff. So maybe we'll share a link to that, because that's actually one of the logical places you would look for that. Okay,
absolutely.
cool.
And they do real good work. They do a lot of good initiatives happening there. There's also it's Swiss, from the Swiss Data Center Association. They also have a label that is looking at some of this, and they want also to include Scope 3. So this is coming up, but it's not as easy as having an API, pushing it to the software developer and saying, look, we have this offset because this was constructed, with concrete or steel, and this is,
okay, so we're not there yet, but that's the direction we might be heading towards. Okay, all right. Well, add some links to that. And now I'd like to pick up the other thing you mentioned about HVO and stuff like that, because you spoke before about Windcloud or Windnode and like data centers running in, like, relying on wind, right? Now we know it's a really common refrain that the wind doesn't blow all the time. And like, it's news to some people that it's not always sunny, for example. So there'll be times where you need to get the power from somewhere. And, in the form of backup power. And like loads of data centers, you said before, they rely on like fossil diesel generators, right? And that can be, it's bad from a climate point of view. It's also quite expensive, but it's also really bad from an air quality point of view as well, because, people end up, you can see elevated cases of like asthma and all kinds of respiratory problems around data centers and things like that. But you mentioned there's options there to kind of reduce the impact or have like more responsible options there. Maybe we could talk a little bit about like what's available to me there if I wanted to reduce that part, for example.
No, happy to go into that. That is something that we are now thinking about quite heavily this year, and we're already presenting on 2 occasions a sense. So the easy options in order to reduce your carbon on the scope 1 part for data center, which is basically that's just the direct burning of fossil resources. And that is the testing of your backup generators. The easy option for that is this so-called second-gen diesel HVO100. And when I realized the key feature of this fuel is, which is about 50% more expensive, is that it doesn't age. Fossil diesel, and especially biodiesel, the first generation, and fossil diesel with biogen, there's always in Europe, there you have a certain degree of mixed in of this. It ages through bacteria biologically, so it's degrading. So which is really bad, because this diesel is sitting there in a tank. You run it half an hour every 2 weeks, and you maybe change the fuel filter twice a year. But if you really have an issue, all of a sudden you use this diesel for 4 hours, and then your system, your filter clocks, and you still have a problem, right? If you
so your backup isn't a very good backup, basically, right? Your backup ceases to be the backup, yeah?
Yeah, so your backup can run.
Like you had one job, right? Yeah.
Yeah. And so how it's mitigated is people try to use pure diesel or heating oil, which is not so prone to it, but still ages. They are recycling or really pumping out the fuel and pumping it in again every 3 years, or they continuously filter it. All of this is either adding energy or cost. And so there's this new form of biodiesel, which is your old frying fat cracked with hydrogen it looks very clear, and it's very chemically treated, that it's not really aging. People don't know really yet how long it stays. They've certified 10 years. Potentially it stays good longer. And it's also burning cleaner. So
it's not going to be so bad, like bad air and stuff as well then?
Yeah. So for the majority of your enterprise IT, your standard data center that's around here, cutting out the whole AI discussion, probably that's the easiest way to do something about that. This is like a drop-in replacement. You just, you empty your tank, you put it in, or you burn your old fuel and put a new. That is something that is, easily increasing the availability of your facility, and you can change with that.
Okay, so can I just try to summarize that? So, because I don't work with data centers on a daily. So there's basically fossil diesel, the kind of stuff that, you might associate with Dieselgate and all kinds of bad air quality issues. And then the kind of the other option, which is maybe a little bit more expensive, you said around 15%, there's something called HVO, which is essentially like biodiesel that's been treated in a particular way to get rid of lots of the gunk, so it burns more cleanly and works better as a reliable form of backup. So the backup is actually a decent backup rather than a thing which might not be a very good backup. Okay, so that's one of the things, and that's the direction that we might be moving towards, and that's kind of what we would like to see more of for the case where you need to rely on some kind of liquid fuel power, right?
Yeah.
Okay.
That is I think is for most people, just a very easy low-hanging fruit to just replace. It does not, most engines are certified for nowadays. All engines run on it. It has the same criteria, properties like traditional diesel. The only thing that's different is it's 4% lighter. Yes.
Oh, I see.
So that's the only real on the specs sheet that's really different.
Okay. All right. So, if I may, so that's one of the options. So you can replace fossil diesel with essentially non-fossil, cleaner, slightly less toxic diesel. So that's one thing that you might have for your backup. Now, I've heard various people talking about, say, hydrogen, for example. Now, hydrogen can come from fossil sources. So people, most of the time, actually, most hydrogen does come from basically cracking natural gas or methane gas, but it can come from green places. And that's another option that you might have to generate power locally. Is that something that people tend to use?
So I think the best reference for hydrogen is like the champagne of our energy transition.
Yeah.
We need to put in a lot of energy to produce it. It's not easy to store. That we need a lot of facilities to actually create green hydrogen. The majority of hydrogen is not green hydrogen, but it's gray or blue, which is basically
it's like carbon capture hydrogen, which is still a bit questionable. Yeah,
based from fossil tracking. So it's potentially, you also have the same goal. Everything that we do for our data, for our clients, is under this extremely short impact of time. We have to solve everything within 5 years' time, not even 5 years, right? And so that's also something that I'm always, sparking good discussion when we talk about SMRs. We have the big pushback for nuclear over in the US and also in Europe. We have voices for that. And the short answer is there are 3 reasons I don't believe in it. They're not quick. They're not cheap. 2 projects just a year ago. There were 2 potential very hopeful projects for SMRs were canceled in the US, and half a year later it was the big thing. The big solution is like, what changed? And then the third point is that is the very German perspective. All the fears or the challenges around the fuel, like getting it, mostly 70% from Russia, or then the waste, dumping it somewhere, is not solved still. And so this is not a 2030 technology, basically. That's the point. What we can do, and what I'm happy also to link, there's a good article from some of the hyperscalers looking into solar combined with batteries, combined with gas-based backup. The gas-based has the one flexibility that it can start fossil, can move to bio, and potentially also can run on hydrogen. So
I see.
This is in terms of the speed with which we are now deploying hundreds of megawatts. Every data center for AI is now 100, 200, 300 gigawatts. Things
megawatts
that
in this case. Yeah.
So it's things that we we're discussing 5 or 1 to 5 gigawatts for the large people, and every other data center is all of a sudden is now 100 megawatts, which used to be like a mega facility just 2 years back. So that build out can only really be achieved not with grids or interconnects; those are too slow. This can only be basically with microgrids.
I see.
Helping that are battery backed and gas based. And the big advantage of this is that if we think about the data center, traditionally data center is a data fortress, right? You don't get in, data doesn't get out. It is is like a bank, in terms of the security measures to do that. And also all of the infrastructure was handled that way. But if we are thinking about the UPS and the gensets not being sitting straight at the data center, or only sitting straight at the data center, but technically belonging to the utility and being able to provide flexible power, because we have this, as mentioned, underlying flexible build out of renewable energy, and we need reliable switch on power, which data centers all have. And so if we can put those together, there's a little bit of this working together, finding the right location where it would make most sense, and then allowing for SLAs and with clients to bidirectional use batteries, gas turbines,
I see.
engine power. This would, help us to transition, especially if we go into, renewable shares 60% and above, and then at latest from 80%. We need those backup technologies, and that is coming back to the question of hydrogen. Hydrogen is a technology that is so expensive that it would need to run all the time, basically. With renewable energy, we have high loads of abundance of energy and only need short times of flexible energy generation, for which gas and batteries is virtually ideal. And so we promote this idea of an energy integrated data center, which has the electrical part supporting into the grid, and is also taking advantage of the heat reuse, especially for liquid cooled facilities, in order to give heat out. And the benefit of that is not only from an economical perspective, but also we see more and more discussions about not in my backyard. If a data center is energy integrated, it's not a question, it's a must-have. And there's also a reason why it needs to be there, in order to be able to stabilize your town grid or your local area. And so that's what we're trying to promote. We got a lot of good feedback, and we see the first, hopefully we'll have the first data center realized with a medium voltage UPS this year, which is like a first step in moving the availability components of a data center, the batteries and the gensets, to a higher area, which a lot of the cost in a data center is from the so-called low voltage distribution. The power that you put in the batteries is also first transferred down, and then it's moved, through the data center until it sits in the battery and then needs to go out. And all of those are rectification steps. And all of this makes,
So do you lose power every single time you switch between?
Yeah.
Oh, okay. So it sounds like there's a shift from like data center as a fortress, where, you could do that before, to like something where you have to be like a bit more symbiotic with your local environment, because for a start, if you don't, you're not going to allow, you won't be allowed to build it. But also it's going to change the economics in your favor if you are prepared to like play nicely and integrate with essentially be a good neighbor. All right. That seems to be what you seem to be suggesting.
That's a perfect analogy, is having like a good neighbor approach, saying, look, we're here now, we look ugly, we're always a box, but we help, powering your homes. We reduce the cost of the energy transition, and we also heat your homes, and that is then a relatively easy sale.
Okay. So that points to possibly that points to quite a different strategy required for people whose job it is to get data centers built. They need to figure out how to honestly relate to communities and say, well, which bits are we supposed to be useful, rather than the approach that you sometimes see, where people basically say, well, we're not even going to tell you who it is or who the company is, but we're going to use all your power and use all your water. That approach stays probably numbered, and that's not a very good strategy to use. It does make more sense to actually have a much more kind of like neighborly approach. And these are maybe new skills that need to be developed inside the industry then.
Absolutely correct.
Okay.
And so you need an open collaboration approach to that, and that is mirrored. So we're trying to be a bit of an example there. And if you talk about, you had a good point in there, which we usually don't have a lot of time to expand on. But I think podcast is a good format for that. You ask, like, where do you get the ideas, or what's the guiding star on that? And so I was fortunate to be an exchange worker, on a farm in Canada, and they introduced me the idea of holistic management, which is like basically a decision-making framework that is based on financially viable, socially viable, and economically viable. And so those three bases are necessary in order to create sustainable decisions or holistic decisions. Those need to be short and long-term viable. And that it has been, my guiding star as an entrepreneur, and really being able to cut out those things. There's a lot of startups, especially in Germany. We had those Berlin startups who all came from a business school, and all of their ideas worked on an Excel sheet always cutting out like a social perspective, you know, and so that was that's the opposite basically of what we're trying to do. And this framework was found by a farmer who first applied it to grass management and cattle farming technically. But it is wildly interesting what he's able to do. He's basically retaking, stopping desertification and reversing effects in subtropical or semi-arid areas. So we'll definitely put that in the notes.
I think we'll shoot for that.
From Allan Savory, which I think he's still alive. He's in he must be 90 now, and it's fascinating. But that was a guiding star, and in order to promote our ideas, a lot of our designs, we put on YouTube, but we also put the files up, the recs. You can download the CD files. We believe they are created with open source tools. So especially in engineering, we only recently really have powerful open source tools for CAD, for single line diagram. So we can give the source files with that, and that is something how we believe that open collaboration and openness helps to build the trust. Builds to build with speed and to really work together. That's
cool.
What we get mirrored in the Open Compute Foundation. Yeah, that is something that we believe is for the challenges that we face as humanity. I believe that only this open approach, and especially an open source, open hardware, open data framework can help us.
All right. Okay. So we're coming up to time. And I just wanted, and you did allude to it a few times, and I just wanted to provide a bit of space to let you talk a little bit about that before we kind of finish up. You spoke a few times about the fact that these models, when you work, bunch of designs for the racks and things are like online and available. And did you say that they're on YouTube? Like people can see the videos of this, or can like download like something in Blender to mess around with it themselves or work with it? Maybe you could just expand on that a little bit, because I haven't come across that before. And
okay.
Yeah.
Sure. So yeah, we initially, when we started, we designed everything and we put it. We still need to, shamefully, we still need to do the push to GitLab and GitHub. Right now we put this model on a construction setup of what's called a GrabCAD, and for our, it's not only our own thoughts to open source this and to build the trust, but it's also our biggest, easiest marketing tool. Create a model, publishing it, put a video to it. We are a bit behind. We have a lot of new and great ideas and things to share. But that's how we approach it. We'll come up with an idea, put it out there, and also make ourselves criticizable. We're the only ones comfortable saying, look, we have the best data centers in the world, because you can download, you can fact check our ideas, and if you have something against it, just give us a feedback, and then we are open to change that. And this way forward, helps us also to approach the biggest companies in the world. They really like this open approach, and they're happy to take the files and the models and to work on that,
So you basically have like models like this is a model of what
our rack, this is our modular data center. These are the ideas behind that, and so that's how we are moving this forward. So people can approach this, they can download it, they can see if it fits, they can make suggestions and
like see if it's tall enough for the door and all the practical things like that.
All those things, and see, okay, we have this modular data center. Oh, the base design doesn't fit in this setup, or we need to change something where we place, the dry coolers or something like that. And so that is really, really good feedback and sparks the discussions.
Yeah, I haven't heard about that before. All right. Well, Karl, thank you so. This has been loads of fun. We've come up to time, and I really, really enjoyed this tour through all the stuff that happens below the software stack for engineers like us, for example. If someone does want to look at this or learn about this, or maybe kind of check out any of the models themselves, if they wanted to build any of this stuff themselves, where should they look? Like, where do people find you online, or the projects that you're working on?
So the the best thing technically is LinkedIn. This is our strong platform. To be honest, we are very, very active there. We publish most there. The web page is still under construction. People already understand what we do from going to that. LinkedIn is great. Trying to reach us and see what we do at the Open Compute Foundations is also often very great. But just technically, via Google, it's very easy to find us on LinkedIn and to reach out.
So Karl Rabe on LinkedIn, WoodenDataCenter. There aren't that many other companies who are called WoodenDataCenter. And then for any of the Open Compute project stuff, that's the other place to look at where you're working, because you're doing the Open Compute modular data center stuff. Those are the ones, yeah?
Yeah, correct.
Brilliant. Carl, thank you so much for this. This has been loads of fun, and I hope that we've had listeners follow us along as well to see all the options and things available to them. All right.
Awesome. It was
hope you have a lovely
pleasure. Thanks so much.
Likewise, Carl. And hope the wind turbines treat you well where you're staying. All right. Take care, mate.
Yeah.
Ciao.
Bye-bye. Cheers.
Hey everyone, thanks for listening. Just a reminder to follow Environment Variables on Apple Podcasts, Spotify, or wherever you get your podcasts. And please do leave a rating and review if you like what we're doing. It helps other people discover the show. And of course, we'd love to have more listeners. To find out more about the Green Software Foundation, please visit greensoftware.foundation. That's greensoftware.foundation in any browser. Thanks again, and see you in the next episode.